Scala is a functional programming language built on the JVM. For more than a decade, this didn't mean anything to front-end web developers. More recently, ScalaJS has brought Scala to the front end. ScalaJS is a project that compiles any Scala program down to JavaScript, so that all of your Scala programs can run on the browser. Haoyi Li has worked on ScalaJS extensively, and he has written an online book about ScalaJS. If you're a front-end web developer and you're looking for a safer way to write your web apps, perhaps in the vein of TypeScript, you will like this episode, or if you're a fan of functional programming. With that, let's get to this episode about ScalaJS. And if you enjoy it, please share it with your friends, or share any other episode you like with your friends. This show grows by word of mouth, and I would also appreciate any feedback. If you want to send me an email, jeff@softwareengineeringdaily.com. I'd love to hear from you. Thanks. Continuous integration is so useful that I've started using it on my own personal projects. SnapCI from Thoughtworks has the fastest setup I've ever seen. I registered for SnapCI with my GitHub account, and after a few clicks, I had continuous integration pipelines set up for a Node.js application and a Rails application that were just sitting on my GitHub account. And I don't want my users to experience breaking changes, so I want to run a large suite of tests for my application every time I push a change. And SnapCI will run those tests quickly, in parallel, on a worker that SnapCI spins up and takes care of for me. Whether you have personal projects like me, or you work at a company that is looking for the perfect tool to improve the deployment process, go to snap.ci/softwareengineeringdaily. SnapCI embodies the lessons that Thoughtworks has learned from 20 years of software deployment, the same lessons that have been written about by Martin Fowler and Jez Humble. Check it out at snap.ci/softwareengineeringdaily. It would support Software Engineering Daily, and you would get to check out continuous deployment. snap.ci/softwareengineeringdaily. Thanks for listening. Haoyi Li is an engineer at Dropbox, and he has worked significantly on the open-source ScalaJS project. He's the author of a free online book called Hands-On ScalaJS. Haoyi, welcome to Software Engineering Daily.
Thanks.
So what is ScalaJS?
ScalaJS is a platform that lets you take Scala source code, which traditionally runs on the JVM, on a Java virtual machine, and compiles it into the equivalent executable JavaScript. You can then take this JavaScript and run it in the browser, which most people do, or on any other JavaScript runtime like Node.js.
So there are multiple reasons why you would build something like this, why ScalaJS would exist in the world. Well, let's start by talking a bit about just JavaScript. When people build a large front-end application, they're usually doing it in something that compiles down to JavaScript. They're probably not just using raw JavaScript on the front end. What are the fundamental reasons why JavaScript is a difficult language to work with at scale?
So I would dispute the fact that people aren't just writing raw JavaScript. I think many people are. But that doesn't change my opinion that it's a difficult language to work with in a large code base. There are a few reasons. One is it's actually a pretty verbose language. So, for example, if you want to have a callback function and you want to refer to the this of the object who's creating the callback function, up until relatively recently, you would need to do a var that equals this, like dance, and then use that inside the callback function because functions did weird things with their thises. There are a bunch of other such things, like you need to use triple equals instead of double equals if you want to say inequality. You cannot just compare arrays for equality. You need to have a helper function to compare them. And there's a lot of these, gotchas that make your code kind of awkward to write. You can't just write the most obvious thing. You have to write the thing that works in JavaScript, and which is not what you'd expect to write in, for example, Python or Scala. The other reason is the fact that it's not typed means it's difficult to do large-scale refactorings, and if you can't refactor, your code quality tends to deteriorate over time because you'll accrete more code but you'll be reluctant to refactor the code to clean it up because refactoring in JavaScript is difficult. And refactor is difficult because you don't have a compiler that checks basic invariants for you, like did I pass in the right number of arguments to this function, or does this object have an attribute of the type I think it has, or of the name with the name I think it has. And the last thing, I guess, is you don't get any real tool support with JavaScript. So you have linters, but for example, JavaScript IDEs don't really provide much help in terms of autocomplete or error highlighting. The linters themselves tend to be pretty superficial, just like formatting linters, and don't really check for correctness bugs. And you put these together, and you end up with a language where you can write things with it and you can make it work, but it's honestly pretty difficult to make it work.
Yeah, and all of these higher level abstractions that we've built on top of JavaScript help with some of these different issues, and then obviously give us other things, syntactic sugars. Why would I want to run Scala applications in a browser? Because we're talking about ScalaJS, compiles down to JavaScript. Why would I want to run Scala in my browser?
There are a few possible reasons. One is you are a Scala programmer with existing skill set and you want to leverage that. So rather than having to learn all the ins and outs of JavaScript, you can learn the basic browser APIs and use all the same APIs from Scala. Or you can use React.js from Scala, or you can use AngularJS from Scala. And you'll need to learn React and Angular, you'll need to learn the browser DOM API, but you won't need to learn the JavaScript intricacies of how to compare two arrays. A second use case is, rather than having a person with Scala expertise, you may have a large existing Scala code base. So for example, there's a NetLogo project on the web which does some kind of simulation and programming language thing where you can simulate various, you can type in NetLogo code and have it run a nice visualization or simulation. And they have a large existing code base in Scala. Their whole NetLogo compiler is written in Scala, for example. And in order to make use of this on the front end, they could have re-implemented this huge project in JavaScript, which would have been straightforward, but very tedious and pretty painstaking. But as an alternative, because of ScalaJS, they are able to just take this huge compiler, take this huge NetLogo compiler, translate the whole thing into JavaScript using ScalaJS, and run it in the browser. In their case, I think it's hooked up to an AngularJS front-end app. So they're not actually using ScalaJS to do the front-end work, but they are using it as a bridge to bring the back-end code to the front-end to hook up to their other front-end code.
Right.
A third reason would be if you are a JavaScript engineer or a front-end engineer and you want to write a large application and you think JavaScript is slowing you down. You think that refactoring is too hard. You think that debugging things when you don't know what attributes an object has is hard. You think that trying to figure out what methods are being called where is too difficult in a large, messy code base. And if you think that static typing would help, one way would be to use TypeScript. And if you think that TypeScript is good, ScalaJS is much more of the same.
Why is that? Let's go ahead and jump into that. How does TypeScript compare to ScalaJS?
TypeScript is JavaScript with types added to it. So in a way, it fixes the JavaScript is untyped problem. It'll check if you pass the wrong number of arguments to a function, or if you pass the wrong type of arguments to a function. For example, passing a user ID as integer rather than a user ID as a base64 string. TypeScript would catch that. What TypeScript doesn't do is it doesn't really give you any helpers to help you program in a more functional programming style, which nowadays is getting more popular. So for example, dealing with immutable data structures or just having variables or values be immutable by default is very handy for catching bugs. Like if I have a large method, even in JavaScript, if I have a large method with lots of local vars inside of it, the chances are I'm not actually going to vary most of those vars. I may vary a few of them, but most of them are just name bindings for me to assign things to a short name. And the fact that I can vary them is purely a source of bugs. I don't want to be able to vary them, but sometimes I'll accidentally reassign it and there'll be a bug and people get confused. So TypeScript, I'm not sure if they do now, but for a while they did not have that. And similar for data structures, TypeScript itself doesn't provide immutable data structures. Like many of the arrays in my program, many of the dictionaries in my program, shouldn't actually be changing after I'm done initializing them. Like some of them should, but most of them shouldn't. And having ScalaJS, you can have this built in that most of your dictionaries are immutable. You can't change them after you've created them. And you can define mutable ones, but by default, they're immutable. With TypeScript, you could use immutable.js to get some of that. But with ScalaJS, it's more of the same. So instead of having a third-party library provide immutability in some corner cases, you have immutability as the broad default. And if you want mutability or you want the mutable variable, you can do it, but it's not the default.
And so one of the main appeals of ScalaJS as advertised is that it is a safer way to build robust front-end web apps. So for somebody who's well experienced in front-end development, the things that you have just listed probably sound safe to them. But for somebody who is maybe less experienced or doesn't totally understand, why are those attributes of ScalaJS that you just listed, like immutability, why are those leading to a safer development experience?
So types and a compiler that checks your types means that you'll never get a name error and you'll never get undefined is not a function error at runtime. And that's a huge improvement in terms of safety. I'm sure anyone who's worked with a JavaScript code base has always... So first, you'll spend all your time in development banging your head against undefined is not a function and type error, something does not have the correct attribute. And after you deploy to production, you're then worried that something will change and you'll be facing the same undefined is not a function problem all over again in production. Because some browser API is not as documented as you'd like and you thought it would return this but actually return undefined. With ScalaJS, undefined is not a function just doesn't happen because the compiler knows what attributes things have, and if you try to access access attribute that doesn't exist, the compiler will just tell you upfront before you run your code. So that's for types. In terms of immutability, a lot of it is just stopping you from doing things which you know you should not be doing. So for example, if I have a global dictionary of, let's say, time zones, and I really shouldn't be changing the way the time zones. Like the world only has so many time zones, and maybe they'll change once every 5 years when some country has a big event. But mostly those time zones should not be changing. But it's very easy in JavaScript to accidentally assign something to the dictionary or remove the dictionary altogether because you can replace it null or undefined or something. And you could do it, but you should basically never do it. But when you do it, it's a bug. And you may know, you as author may know you shouldn't do it, but someone coming in like 6 months later may not know, and he may make a change that you knew you shouldn't do and end up causing a bug. So having immutability would mean that if I try to modify the time zone table in my, let's say, front-end web app that deals with time zones, the compiler would immediately tell me you're not allowed to do that. And granted, I could change enough code to make myself allow myself to do that, but I won't accidentally do it. Like I won't accidentally change a dictionary from a mutable dictionary from an immutable dictionary to a mutable dictionary. Like I can do it intentionally if I know what I'm doing, but the fact that I need to do it is kind of like I know what I'm doing step, and you won't screw up and do it by accident.
Sure. So you've touched on TypeScript, but there are these other JavaScript variations that give some of the same advantages of ScalaJS, sorry. Like ClojureScript, there's ClojureScript, there's Dart. How do these other things compare to ScalaJS? Why is ScalaJS the perfect medium of features for kind of functional JavaScript programming with syntactic sugar built on top of JavaScript?
So I wouldn't say it's perfect, but I would say it's pretty good.
Okay, sorry.
Yeah. So
overstatement.
Scala has its problems, and you can talk about those later if you're interested. So comparing ScalaJS to other compiled to JavaScript languages, every case is different. So for example, ClojureScript. ClojureScript is older than ScalaJS, has a small but passionate community. It has all the functional programming immutability stuff that ScalaJS provides, and none of the type checking stuff. So in a way, it's kind of like the dual of TypeScript. TypeScript provides types with no immutability and functional programming. ClojureScript provides all the immutability and functional programming, but without types. So if you're the type of person who likes types and who doesn't mind waiting a bit of compile time and spending some time annotating what types things are in exchange for the compiler helping you catch bugs, if you're that kind of person, then you'd prefer ScalaJS over ClojureScript. Compared to Dart, to Google Dart, ScalaJS is, in many ways, a more ambitious language than Dart. So Dart is kind of like what you would get if you mixed JavaScript with Java. And it's, in some ways, an improvement, in some ways, more of a sideways transition. Whereas ScalaJS goes a lot further in terms of making things expressive, making things easy for a developer to do when the developer wants to do so. So, for example, ScalaJS lets you easily define a HTML templating system within Scala without needing to load external template files and have it be just as easy to use as external template files, but also have type checking, so it's even safer than external template files. Another factor in comparison to Dart is that ScalaJS lets you leverage the existing Scala ecosystem very well. So, for example, ScalaJS makes use of Scala's package managers, package distribution formats, build tool, dependency resolver, and dependency conflict resolver. ScalaJS makes use of Scala's libraries. So many Scala libraries from the Scala JVM land can be cross-compiled to ScalaJS without a problem. And the server-side JVM Scala is a way bigger ecosystem than the server-side Dart. So ScalaJS is able to leverage all this stuff, and you basically get it for free. So for example, if you use a Scala IDE, ScalaJS just works out of the box. It doesn't even know it's ScalaJS because it looks just like any other Scala, and everything just works. Jump to definition, refactoring, everything. And all the libraries from Scala JVM land. For example, there's this well-known functional programming library called ScalaZ that some people are a bit scared of because it's pretty deep, but it's very powerful. And there's many years of effort gone into this library. And it got cross-compiled to ScalaJS with like 2 lines in the config file, just to say add the ScalaJS plugin and publish it. So that's the kind of thing which ScalaJS benefits from that Dart, because it doesn't have a big existing ecosystem, kind of struggles with. Like, how many Dart packages or how many Dart books are there out there? There are some, but not as many as there are Scala. And
totally.
Yeah.
So, okay, you mentioned those negative aspects of Scala. I would love to hear your opinion of what are the downsides of using Scala.
Sure. The standard build tool, SBT, is very confusing. It's almost famously confusing. It used to be called Simple Build Tool, but that was almost a bit too ironic. So now they've renamed it, so it's now a Scala Build Tool. No longer simple. The compiler is very slow. It is probably one of the slowest compilers in the world. So incremental compiles tend to be in order of a handful of seconds, like 1 second to 5 seconds, which is okay, but not as fast as just refreshing JavaScript in the browser. Or for the matter, on the server side, like refreshing a Python application is much faster than refreshing a Scala application. The language has, in my opinion, a slightly ugly syntax. So it's not terrible. It's kind of like a C-style language that looks not too different from JavaScript. But there are lots of quirks to the syntax that trip people up when they first get started with it. The language lets you do bad things. So it lets you do complex things, and sometimes those complex things are bad. So it's very easy to define code that you think is clever, but everyone else gets confused by and they end up hating you. So traditionally, Scala had a lot of this problem where the community did a lot of, for example, operator overloading, where you define an operator that's /:/ greater than, and everyone will look at your operator and wonder, what the hell is that? Or operator less than ++ equals. And you can do it, but you probably shouldn't, and Scala won't stop you from doing it. In the past, people did it a lot more. Nowadays, there's a bit more of a consensus that you shouldn't define crazy operators. And in general, you shouldn't try to be too clever with your code. But it's definitely a risk. And if you write Scala, it's something that you have to stop yourself and stop your colleagues from falling into.
Yeah, I've been at companies before where there is a Scala some set of Scala files that nobody will touch because it's in some really opaquely written Scala code, and it's just in a mostly Java stack, and it seemed like the norms for how to write Scala were not as well formed. So I mean that's probably an exception, because probably companies that use Scala maybe use it more, but this was like some example of like a one-off Scala project and nobody knew how to read it. So
I don't think that's that exceptional. Like Scala is a very different language from like Python and Java. If you're writing Python and Java, even if you've never read the code before, you don't even know the guy, you kind of know what the code will look like, even without code review, without any sort of oversight. Whereas in Scala, you definitely need code review as like a mandatory thing, just to make sure people don't go off in the deep end.
Definitely. So people who are using Node on the back end are often talking about, it's so great to use full stack JavaScript because you don't have to do this context switch from language to language. Although, we're maybe not, a lot of the people are not using full stack, or are not using JavaScript on the front end as much as they are using abstractions built on top of JavaScript. But this might compare to using ScalaJS on the front end and using Scala on the back end. What is that experience like? What are the advantages of using full stack Scala?
The experience is wonderful, and the advantages are everything you can imagine they would be. So you don't end up rewriting your code just because you need to run it on the other platform. You just put the code in a shared folder, and both sides can share it. In some ways, it's better than Node. For example, if you put code in the shared folder in ScalaJS, you are restricted to the subset of APIs that both the client and the server have available. And if you accidentally venture outside that subset of APIs and use something that only works on the client or only works on the server, the compiler will complain at you. Whereas on Node.js, there's no such check, and because it's JavaScript, so everything's at runtime. You can do everything you'd expect. You can have shared code that the client and server will both use. You can have shared code depending on different implementations on the client and server. For example, you may have a JavaScript, you may have a JSON library or serialization library that uses the JavaScript's JSON.parse on the client, but uses some Java-based JSON parser on the server. And all that works just as you'd expect. You have different implementations in the JavaScript and ScalaJS and ScalaJVM folders, and you have the shared folder which can depend on both of them and use it as if it's one implementation. The full stack is pretty nice. You will end up writing different code on the client naturally because it's a different environment. But with ScalaJS and ScalaJVM on the server, you don't end up unnecessarily writing different code. Like you write different code for parts that should be different. And anything that should be the same, you just put in the shared folder and it is the same. So any like global constants, any shared helper methods, any algorithms, even libraries can be shared. So for example, the ScalaZ library I mentioned earlier, it's cross-compiled to both JavaScript and Java. So if your project depends on it, you can use it on both sides and it works great. And the whole dependency chain can be shared if it's possible.
So there is an ease of client-server integration when a software stack is using both Scala and ScalaJS. Could you talk more about that client-server integration? What makes things easier?
Sure. Using the exact same serialization library on the client and server means you can literally just throw things across the network and have them materialize on the other side more or less perfectly. So if I want to throw some data structure across, I just do it, and it's serialized on the JavaScript end, and it's deserialized on the server JVM end. But because it's the same Scala code doing both sides, it's guaranteed to be in sync. I don't need to maintain two separate implementations. Some other things are pretty novel. So for example, ScalaJS and ScalaJVM let you type check your AJAX calls. So I can basically call a method, so to speak, in ScalaJS that's actually an AJAX endpoint and get back a promise. In Scala, they call it the future, but it's equivalent to a JavaScript promise, and get back a promise of the result of that method because it's asynchronous when I make an AJAX call. But if I rename the endpoint and I forget to rename the client, I'll get a compilation error. And if I make the endpoint return a different type, for example, if the endpoint was returning a list of strings and I change it to return a list of tuples of strings, and if I don't update the client, I'll get a compilation error. What this means is that your client-server interaction becomes really safe. Like you don't get 404s and 400s on your AJAX calls anymore. You just don't. The routing, if it compiles, it will definitely find the endpoint. And if it compiles, it will definitely serialize and deserialize properly. So the logic inside, well, that's a separate problem. But at least a base level of I can get the data structure from here to the server and get the result back in a reasonable format. That is all handled for you and type checked for you. So you will not make a mistake there. And even if no matter how tired you are, the compiler will not let it run until it's correct.
Okay, well, let's talk more about the process of interpretation or compilation. What was involved in writing a Scala to JavaScript interpreter? I'm pretty sure you didn't write it, or did you contribute to it? I don't know if you contributed.
I contributed like 10 commits out of 5,000. So
Okay.
I know a bit about it. Like I've seen the internals once or twice.
Yeah.
I can talk about it in short,
Please do.
not in detail, but basically Scala normally compiles to Java bytecode. So what happens is normally
Directly to Java bytecode.
Yeah, so you have the Scala code, which is this functional programming thing, and it goes through a series of phases where the compiler turns it more and more Java-like until it eventually becomes bytecode. So first, all the functional programming stuff disappears. All the types will get resolved and disappear, get erased in Java land. The Scala specific features, like Scala has multiple inheritance via traits, they're called, get converted into the equivalent using Java, where in Java they become either interfaces or they have some kind of like static methods which you get called in order to simulate multiple inheritance. And after a bunch of these lowerings, you end up something that kind of looks like Java. And after more of these lowerings, you end up with Java bytecode. So at a high level, the ScalaJS compiler more or less cuts in at the level of not yet bytecode, but more or less looks like Java. So after the Scala compiler has turned the Scala source code into something that more or less looks like a Java-like syntax tree, it then takes a Java-like syntax tree and turns it into a JavaScript syntax tree. And it follows. It's not as flexible as what JavaScript you write by hand. It's kind of slightly more rigid. So everything will have a class. Everything will be defined before they're used. It won't use dynamic attribute lookups by strings. Everything is like so-called static JavaScript. It's kind of like the JavaScript you'd write for TypeScript or JavaScript you'd write for the Google Closure compiler, which also has type checking. It's also Java-like. And from that JavaScript, it will then optimize it based on what it knows about the code. So for example, it knows what type everything is. It knows what types are never used anywhere in the program. Those can be removed. It knows what methods are calling what other methods. So if you're writing freehand JavaScript, that's kind of hard to tell because you don't know what types things are. And you don't know if someone's doing something dynamic like using object.getHas attribute and iterating over attributes of objects. But for the Java-like JavaScript that ScalaJS ends up with, it's a lot more rigid. So you know what type everything is, you know where things are coming from, you know where variables are coming from, and you know what attributes resolve to and what methods resolve to. So you know where all these things come from, and you know what's not used. So first you take away all the things that are not used. Before we were doing that, the output JavaScript would be 20 megabytes, which was huge because the whole standard library get compiled and this huge thing. But once you take away all the things that are not used, it ends up being like 1 or 2 megabytes. So kind of big, but a lot smaller. After you take away all the things that are not used, you can then begin like optimizing it for real. So inlining methods, if you have a method that's only called once, rather than having this big verbose method definition and then calling it once, you just put the contents where it's called. Inlining objects. So if you have if you instantiate the object in a local function and only use it in that function without passing it anywhere, well, might as well just put the fields of the object in that function rather than having the object definition. And that lets you kill the object definition and makes the code even smaller. And you can do like constant folding and constant propagation. And there's a bunch of these phases which make the JavaScript from basically what came out of the Scala compiler to something that's really pretty tight and optimized. And after all this is done, you end up with maybe 700, 600 kilobytes worth of JavaScript. So half as much as you started off with after removing dead code, but still quite a lot. And that's because a lot of it's still very verbose. For example, Scala compiler will generate very verbose internal names for things. And because for Java bytecode, it doesn't matter what your name is, it ends up being bytecode. But here we didn't convert to bytecode. So we still have the very verbose internal names. So you end up with 600, 700 kilobytes of JavaScript. And instead, we feed it through the Google Closure compiler. So the Google Closure compiler is this open source project which has a really powerful optimizer, where if you write JavaScript with a certain style, so none of the dynamic stuff and none of the weird like JavaScript specific things. Basically, if you write JavaScript that looks like Java, the Google Closure compiler will be able to take it and optimize it all the way down. So at the end of the day, you end up with maybe like 100 kilobytes of JavaScript from the original 20 megabytes. And it's really unreadable. It's all compressed down into like one character names for methods, one character names for classes. Things have been inlined all over the place. But you get source maps that help you debug it. So it's not impossible to debug. It's actually pretty reasonable. And that's the end of the line when you ship it out to your users, and you end up with a JavaScript blob, which is about the size of a small image. So it's not nothing, but it's not terrible.
How does DevOps change in the age of Docker and Kubernetes? At apprenda.com/SE Daily, you can find a webinar about DevOps in the age of Docker and Kubernetes, featuring Gene Kim, author of the Phoenix Project. Gene was instrumental in popularizing the DevOps movement, and at apprenda.com/SE Daily, he will be discussing the topic with speakers from Google and Apprenda. Docker and Kubernetes have exploded in popularity, and with these changes, there has been a shift in focus from automation to full orchestration in distributed environments. Learn from Google's experiences running containers and clusters at massive scale, and learn from Gene Kim's explanation of the state of DevOps at apprenda.com/SE Daily. Thank you to Apprenda for being a continued sponsor of SE Daily. And if you're a listener who wants to support Software Engineering Daily while also learning about DevOps and Docker and Kubernetes, check out apprenda.com/SE Daily. Apprenda provides cloud platform software that works with your existing applications and infrastructure. So if you are looking for an enterprise platform as a service, you might also want to check out apprenda.com/SE Daily. Thanks again, Apprenda. How fast is that JavaScript code after it gets ported from Scala?
1 to 3 times slower than raw JavaScript.
Okay.
So if you compare idiomatic Scala to idiomatic JavaScript, there's some slowdown, but it's not a lot. This is mostly due to all the optimizations that happen. Before the optimizations, it's 20, 30 times slower. But after the optimizations, it's 1 to 3 times slower.
So ScalaJS is obviously interoperable with React.js and AngularJS. What was involved in getting that interoperability? Because the language interoperates quite nicely with those front-end frameworks.
Yeah. So ScalaJS defines a way of letting you define as a programmer what we call facade classes. So if you've ever written Java, you have these native classes and native methods where you write a stub, but you don't write in the implementation, and it's basically a promise to say that here is a method, and I promise it will be implemented by the C runtime or whatever in Java. And ScalaJS has something similar where you can write basically a stub class where all the implementations are missing. So you know what methods it has, you know what types they take, what types they return, but you don't know how it's done. And you basically mark this as a Scala, as an external JS native class. And this will say that I know that in JavaScript land, this class exists. And when I call a method of this class, I will call the JavaScript method. And I know that when the method returns I know that when I call the method, I need to pass in these arguments, and the method returns, I'll get an argument of this type. So that means that writing the facades for example, interacting with the JavaScript DOM APIs was just a matter of manually transcribing all the different, of semi-automatically transcribing all the different methods and classes which exist in JavaScript DOM. So there are a few hundred of them, and it's tedious, but it's not impossible. You just sit there and do it. And you end up with a set of Scala classes and interfaces, which basically represent the objects of the DOM, and you can treat them as if they're Scala classes and interface and Scala objects, but they actually will call the DOM APIs under the hood after the compilation is done. So you can do that for any JavaScript class or any JavaScript library, not just the DOM, but you can do that for Angular, you can do that for React, you can do that for jQuery, and it works. And after that, you may want to put a wrapper on top of that if you think that, for example, the Scala language tends to use different conventions than the JavaScript language. So for example, JavaScript, the React will use JSX. It's like a XML syntax for writing the literals. For writing HTML literals, the ScalaJS React facade, instead of using XML syntax, uses more like a Scala HTML builder syntax, which looks different. Whether it's better or worse is a matter of taste, but it's more idiomatic Scala to do it that way. And so the person who wrote the ScalaJS React facade wrote this small wrapper to do this in order to make the React library feel a bit more like Scala, even though under the hood it all will call down to React. If you want to do it for a library, like if you have a library which you're not using, which no one has written a facade for, but you want to use it, you can always call it so-called dynamically. In which case you don't get any type checking, but you can call whatever method you want, whatever attributes you want, and it all works dynamically. If you want to take the time to write a ScalaJS facade for that library, you then get something that's even better than using JavaScript, in that you can interact with this JavaScript library, but the Scala compiler will tell you when you're using a JavaScript library wrongly based on the facades you've written. So that's kind of nice, and that's what it's like.
Can you give me a perspective for what it's like to actually use ScalaJS in practice, perhaps on a larger program? How does that development workflow look? What kinds of tooling do you have?
Sure. So typically, everyone who's using ScalaJS will be using the SBT build tool. So SBT has a watch and recompile functionality. So you basically set it in a recompile loop, and every time you change a file, it will recompile the code and regenerate the JavaScript. You can also set it up to automatically refresh the browser when the recompile is complete, and that's something that many people do. So when you first check out a large ScalaJS codebase and you hit compile, you shouldn't be surprised if you end up waiting like 30 to 60 seconds for the first compile, because the Scala compiler just is that slow. Even for just a few thousand lines or maybe 10,000 lines. But after that first compile, the incremental compiles tend to be on order of 1 to 5 seconds. So you'll change the code in your editor. Most people use IntelliJ or Eclipse or Sublime or something. You'll change code in your editor. You'll save it. It'll automatically pick it up, recompile 1 to 5 seconds later, depending how big the code base, big the change was. The browser will automatically refresh, and your code will be running in the browser. Practically, compared to JavaScript, you end up looking at the browser a lot less, because the editor and the compiler will tell you a lot more. So for example, if I'm doing a large refactor in JavaScript, I will make a bunch of changes, and I will constantly be refreshing the page to look at what errors I'm getting in JavaScript in the console, because in JavaScript, all errors are console runtime errors. In ScalaJS, if I'm doing a large change, I may spend like an hour or even several hours without ever actually running the code, because I'll make the change and the compiler will guide me, given this change, what other parts of the code are now incorrect, and I will fix them, and it'll tell me now those are fixed, what else is incorrect, and I'll fix those. And maybe even it may take an hour or 2 hours before I'm done fixing everything the compiler's done is complaining about. But after I'm done with that, usually it's a pretty short amount of actual runtime executions to flesh out the remaining bugs and have something that actually works again.
Are there any unique challenges of building a large, non-trivial ScalaJS application?
I haven't actually written that large applications. So the largest applications I've written cap out at a few thousand lines of code. Other people in the community have written bigger ones. So from what I know, there are a few. So the compile times do tend to get annoying after a few tens of thousands of lines. So the people who are working with like a 30,000 line or 50,000 line ScalaJS application do complain about the edit refresh time, how long it takes, because it does slow down a bit. Apart from that, well, ScalaJS isn't JavaScript, so I guess it may be difficult to get it may be difficult to get your front end people who are experienced in JavaScript like on board with such a thing, because like ScalaJS community is pretty big, but it's nowhere near. It can't be compared to the JavaScript community, like totally different orders of magnitude. And if you have a large ScalaJS application, it would be difficult for a JavaScript programmer to jump in and immediately be productive. Like they can be productive, but it will take some effort and some time to onboard. Yeah, I'm not sure what else because I don't have that experience. Yeah.
No, it's fine. It makes sense. That's helpful. So in your online book, you write about some of the advanced usages of ScalaJS. The first thing you talk about is a functional reactive user interface. This is related to the FRP, functional reactive programming paradigm. So what's a functional reactive user interface?
Functional reactive programming, at least as I understood it then, was rather than having variables that have a value and can change later, or rather, let me rephrase that. Rather than having a variable that anyone can set and you can read to have different values at different times, you have these things called signals. And the interesting thing about the signal is it encapsulates the idea that this is a variable that can change. And what can you do with a variable that can change? Well, you can listen for changes. So if I have a signal that depends on your signal, and your signal has let's say a value 1, and my signal ends up being the value, let's say ONE. Let's say my signal converts your signal's value into English. If you change your signal to 2, then my signal had registered the observer on your signal, so my signal would automatically update itself to TWO. And similarly, I can have a whole chain of signals, each one depending on previous signals, in not just in a single like line, but in like a directed graph style. So that normally when I have a large computation in say like normal JavaScript, I have a bunch of input at the top, I have a bunch of local variables in the middle that depend on the input, and I have a bunch of output at the bottom. But the problem happens when one of the inputs changes, and the question then is, what do you need to recompute? So if I recompute the whole thing, which is equivalent to refreshing the page every time something changes, it's wasteful. It takes too much resources even for a small change, and it's kind of annoying for the user. If I recompute too little, you end up having weird inconsistencies where I added you as a friend, but you haven't showed up in my friends list yet. And I'm not sure how to get you to show up because I added you, but that's all I can do. And you haven't showed up because I recomputed too little. And so you end up in this very annoying state where you have this big computation and you have to manually declare every time something changes, what do I need to update? So that's the status quo in normal, like top to bottom JavaScript programming. So with the so-called functional reactive programming paradigm, with these signals, I declare this top to bottom computation based on signals, and each signal will keep track of, while I was computing my current value, which other signals did I require? Which other signals values did I make use of? And when you how should I phrase this? So you compute this result of this computation, and not only do you get the result, you end up with this like dependency graph of signals. And so when I change one of the signals at the top of the computation, I have this graph structure which can automatically propagate and recompute the necessary signals, and propagate the change all the way to the bottom such that only the things that need to change. And I never recompute too much, And just as importantly, I never recompute too little. So this is kind of a neat idea. It's different from what React.js does. It's different from what AngularJS does. I don't know that many people who are using it in production, but it's an interesting paradigm that was easy to implement in ScalaJS. The library itself that implements this is something like 1,000 lines of code. So it's not like a huge complex system, but it's just a neat little demonstration of what you could do with ScalaJS.
Sure. No, we've done several shows about this recently. Particularly when I'm talking to, there was a show recently about reactive streams, and there was one a while ago about RxJS. So why is ScalaJS particularly good at building these functional reactive programming paradigm, like functional reactive UIs?
I don't think it's particularly good. It just happened that the functional reactive library was a project I had done recently when I started using ScalaJS. It actually originated as a Scala JVM library, and now it runs on both. But it was a neat project I had done for my senior thesis in college, and I was like, okay, I have this ScalaJS thing that can compile Scala to JavaScript. I have this JavaScript library. I have this Scala library I wrote that I understand. I should be able to cross-compile it, and so I did, and I wrote up a little section on the book about it.
Yeah, okay. So another advanced concept that you discuss in your book is asynchronous workflows. What's an asynchronous workflow?
Are you familiar with the async and await in JavaScript?
Yeah.
Yeah, you basically have it in Scala too, and it's the same.
Okay.
It's implemented differently and has a few subtle differences, but as a first approximation, you have async and you have await, and rather than having these callback pyramids, you have async and await, and it does what you'd expect in JavaScript.
Right. So when we're talking about the multi-threaded concurrency world of Scala versus the single-threaded world of JavaScript, how is that gap bridged? Because these are obviously very different threading models.
Sure. Surprisingly, the Scala JVM community is also largely based on a single-threaded model. So although the Java runtime, the Java virtual machine is multi-threaded, the focus of the Scala community in concurrency has largely been around actors. So what an actor is a single-threaded event loop, which has its own mutable state and interacts with other actors by putting messages in to trigger their event loops. But each actor itself is single-threaded. So when you look at the Scala standard library, most of the abstractions around concurrency do not depend on being multi-threaded. So you have actors, which you can have them you can have them share an event loop, you can have them on separate parallel event loops, doesn't really matter. You have promises, which in Scala are called futures, which behave more or less the same as JavaScript promises in that they are basically an encapsulation of callbacks and don't really depend on being on multiple threads and can work on the same thread and can function just as well on a single thread. And so all that works the same in ScalaJS as it does in Scala JVM. So while in JavaScript you may be using Bluebird or A+, or whatever the most popular promise libraries are nowadays, in ScalaJS you use the Scala standard library futures or promises, and they work just as you'd expect. They run asynchronously. More or less every operation works as you'd expect. The only operation that doesn't work is you cannot block on a promise in ScalaJS like you can on Scala JVM. And the reason for that is on Scala JVM, you can block a thread while other threads may complete the promise and continue. And in ScalaJS, there are no other threads. So you can't block on the promise. But other than that, everything just works, and it's pretty seamless.
So are you using ScalaJS in your work at Dropbox?
I'm not. Yeah.
Okay. Is that just because it's not everybody there is familiar with it and you want to keep a somewhat portable code base?
It's a few reasons. One is we don't use Scala, so onboarding everyone to ScalaJS would be a difficult sell. We don't use Scala, we don't use Java, so it's a different community.
Oh, that's right. It's Python.
It's like a Python C ecosystem. All our tools are based around that. And also, like when I was working, I'm no longer working on the web team at Dropbox. But when I was working on the web team, ScalaJS was not mature. It's pretty mature now, but when I was working on the web team 3 years to 2 years ago, it was not ready for general usage. And I guess a third reason is that it would be kind of clunky to integrate into our own custom like build system and all that, but that can be solved. It's more about a matter of maturity at the time and just the cost of onboarding.
Understood. So how much adoption of ScalaJS has there been in the broader development ecosystem?
It's hard to say exactly. So if I remember correctly, the ScalaJS plugin gets downloaded from the package repository something like 10,000 to 20,000 times a month. So I'm not sure how many of those builds are continuous integration builds, but lots of people are downloading it. We have a Gitter channel, like a chat channel attached to the GitHub account by Gitter, and that tends to have about 1,200 people in it at any time, which is a good number. So for example, in comparison, the Scala Gitter channel for the more traditional Scala ecosystem has twice as many people. So it's probably not proportional. Like the ScalaJS community is probably more chat-centric than the Scala JVM community. But 1,200 people in chat, if you consider that not everyone who uses the system will end up in your chat channel, so maybe like 1 in 5 or maybe 1 in 10 people who use the software maybe end up in the chat channel as a random ballpark estimate maybe. You're looking at thousands to 10,000 plus people using it. So it's not huge, but it's not small either. It's a good number. And I know a bunch of companies are using it in production. I know Twitter landed some ScalaJS in their monorepo code base, for example. And like SAP is advertising for a ScalaJS developer if you know any. So these people are using it for reals.
Yeah, Twitter seems like it would be a good fit because they use so much Scala on the back end. So there was this interesting question in the FAQ about ScalaJS, about Asm.js, and I'd love to discuss this a little bit. Asm.js, well, maybe you want to could you explain what Asm.js is and explain, the answer to the question, can you run ScalaJS on Asm.js?
Sure. Asm.js is a subset of JavaScript that looks like assembly and is basically executed as assembly. So it does not have the concept of objects. It has numbers and it has loops and if statements and functions. And it doesn't have any of the JavaScript like objects or prototypes or any of that. So the goal of that is to say that, well, if we can identify this subset of code, it's very easy to optimize it because we can directly translate it to assembly. So normal JavaScript just-in-time compilation depends on lots of clever things like you'll try and guess whether an object is necessary or whether it can be elided, or they'll try and guess like what type an object is or guess what type of value is in order to optimize the code paths, or guess like what method this is actually calling. But with Asm.js, you don't have objects and you don't have methods. You only have top-level functions. You don't have types. You only have numbers. And as a result, Asm.js ends up being really easy to optimize to very fast code. So Mozilla started doing it. My impression is that the Chrome people also optimize it. Not sure whether they specially handle it, but Chrome does end up optimizing it to very fast code, and so does Internet Explorer, or what they now call Edge. So if you want to compile C code or C++ code to assembly and then convert that to JavaScript, you can do so. And there are a bunch of demonstrations running like C++ games in the browser as Asm.js. And the performance is okay. Like you end up with 20, 30 megabytes of JavaScript because the assembly ends up being really verbose JavaScript. But you download that and when it starts running, it's acceptably fast. So ScalaJS will not work on Asm.js for the foreseeable future. And that's because ScalaJS depends a lot on trying to mirror how JavaScript works. And Asm.js explicitly throws out all the JavaScript things in order to look like C++ or look like assembly, such that C and C++ can compile to it. So as an example, ScalaJS classes are JavaScript classes as a first approximation. ScalaJS methods are JavaScript methods. ScalaJS lambdas, like inline callback functions are JavaScript inline callback functions. Asm.js does not have classes, does not have methods, and does not have inline callback functions. Like the ScalaJS garbage collector is the JavaScript garbage collector, and Asm.js does not have garbage collection. The ScalaJS inheritance hierarchy maps to the JavaScript prototype chain, and Asm.js does not have inheritance or prototypes because it's basically assembly. So, like, while in theory it might be possible to port it over, in practice it's probably not going to happen. And one consequence is that because Asm.js basically implements their own everything. So, for example, if the C++ methods and C++ classes will live in like this big byte array inside your Asm.js program, you can't interop with JavaScript easily. Like, I can't give a JavaScript object to the Asm.js functions or give a Asm.js object to a JavaScript function. Like, one of them lives in the JavaScript heap, one of them lives in the Asm.js binary byte array. So even if we did convert ScalaJS to Asm.js, we would give up all the nice interoperability that we've been taking for granted. So I doubt it's going to happen.
Well, Haoyi, thanks for coming on the show. This has been a great conversation. I think we've covered most of the high-level questions about ScalaJS, and I want to appreciate you for coming on, and thanks for publishing your online book. I hope people check it out.
Yeah, thanks.
Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks again, Symphono.
Wow.